Hello everyone, I am Dr. Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about nitrene, carbene and free radical reactions. So I will discuss about the introductions, types, formation, stability, synthetic applications. So free radicals. What is free radicals? You can see here A and B homolytically fission give the free radicals. Here is the example. So when a covalent bond undergoes homolytic fission, the two departing atom takes one electron of the bonding pair of electrons. The two fragments carry an odd electron each and are called free radicals. Now characteristic of free radicals. You can see here odd electrons, incomplete octet, unstable, short-lived and highly reactive, shape and hybridization sp2 and paramagnetic in nature. Now types of free radical: 3 degree, 2 degree, 1 degree and methyl. There are 3 types of free radicals based on the number of alkyl group attached to the carbon carrying the odd electrons. This is the 3 types. Now formation of free radicals. You can see the acetone when treated with light, it gives this free radical and this free radical. So homolytically cleavage of covalent bond generate a pair of free radical. Following are the sum of the method used for the generation of free radical. Photolysis. In this method, a suitable organic molecule is subjected to UV radiation. The organic molecule absorbs radiation in the ultraviolet or visible range. The cleavage of molecules by two parts by using UV light is known as photolysis. Now, thermolysis. In this method, the organic substances is heated at the suitable temperature. Example, benzoyl peroxide. You can see the formation of radicals, benzoyl free radicals. Now another example you can see here, the radical molecules may undergo decomposition to form another free radical. So after removing the CO2, now the free radicals. Now stability of free radical, you can see the 3 degree more stable than 2 than 1. So resonance, hyperconjugation, inductive. This is the reason. Resonance much more than hyperconjugation greater than inductive. And tertiary, secondary, primary methyl free radicals. Now allylic free radicals or benzylic free radicals. So allylic free radical less stable than benzylic free radicals. You can see due to resonance. Synthetic applications. Sandmeyer reaction. It is used to synthesize aryl halide from aryl diazonium salt using copper salt as reagent or catalyst. You can see the conversions. Now Gomberg reaction. It is aryl coupling reactions via diazonium salt. So formation of diphenyl. Now carbene. What is carbene? A carbene are highly reactive species having a lifetime less than 1 second, and these are defined as neutral divalent carbon species in which the carbon has 6 electrons in its valence orbital, 4 covalent bonded electrons and 2 non-bonded electrons. You can see this methylene and these 2 electrons. Now characteristic of carbene. It has 6 electron, neutral species, incomplete octet, electron deficient species, electrophile, highly unstable, very short lived. Examples, you can see the phenyl carbenes, dialkyl carbenes, dichlorocarbenes, bromochlorocarbenes. Now types of carbene. My friend, 2 types, singlet carbene. So singlet carbene, the non-bonded electrons are paired and are in anti-parallel speed. You can see in this example. So shape trigonal, diamagnetic, no magnetic moment, Violet-Schultz rule, hot methylene and spin state is equal to singlet and sp2 hybridized. So p orbital empty, sp2 orbital full, then you can see the sp2 hybridized. Now triplet carbene. The non-bonding electron in the triplet carbene occupy different orbital and has opposite spin, shape linear, paramagnetic means magnetic moment, it follow the Hund's rule, cold methylene, spin state 3, that's why it is triplet and sp hybridized. So remember the difference between triplet and singlet carbene. Now formation of carbene. From diazopropane, when treated with light, it gives dimethyl carbene. Now you can see from ketene you get the carbenes. From epoxide you will have the dimethyl carbene and acetone. And from diazirine you can see the formation of dialkyl carbene. Now stability of carbene. Triplet carbene are more stable than singlet carbene because with 2 electrons in different orbitals there is a less electrostatic repulsion than both are in the same orbital. In halogen substituent carbene, the singlet carbene are more stable than triplet carbene due to overlap of their lone pair of electrons to the empty p orbital, thereby stabilizing the singlet carbene. The order of stability of halogen substituted carbene CF2 is more stable than the CCl2, which is more stable than CBr2. This is due to bond length, which provides more extensive lateral overlap of the respective p orbital. Now synthetic application. You can see the aniline at giving the phenyl isocyanate through the carbene formation. Another example, Remer-Tiemann reactions from phenol to salicylaldehyde. This reaction also happen with the carbene. Nitrene. So nitrene is the nitrogen analog of carbene. These are defined as the neutral monovalent nitrogen species in which the nitrogen has 6 electrons in its valence orbital, 2 covalent bonded and 4 non-bonded electrons. Now characteristic of nitrene, it has 6 electrons and are electron deficient. They are regarded as electrophile or Lewis acid. They are short-lived and highly reactive due to their strong tendency to accept 2 or more electrons in order to complete its octet. Now types of nitrene. Singlet nitrene. In singlet nitrene, the 4 non-bonding electrons on nitrogens are present as 2 pairs having anti-parallel spin and has no magnetic moment. Diamagnetic, they are sp2 hybridized. You can see the situations of nitrogens. So triplet nitrene, in triplet nitrene, the 4 non-bonding electrons are present on nitrogen to form of lone pair, 1 lone pair and 2 unpaired electrons having parallel spin and has magnetic moment, paramagnetic, and they are sp hybridized. So formation of nitrene, you can see with the eliminations, formation of nitrene, example here. Now from azide, thermal or photolysis decomposition of azide give nitrene, and from sulfenyl amine, pyrolysis of the sulfenyl amines generate nitrines. Now stability of nitrines. Nitrines are very reactive species and cannot be isolated. However, a nitrine has been trapped by its reaction with the carbon monoxide to isocyanate. So azidobenzenes and treated with PHN, it gives the ethanone, and nitrene can also be trapped in presence of ethylene. So synthetic application, Hofmann rearrangement. When an amide is treated with bromine in alkali solution, it is converted to primary amine that has 1 carbon atom less than the starting with amide, and this reaction is known as the Hofmann degradation, Hofmann rearrangement. You can see the benzamide and formations of aniline by removing carbon dioxide. Now Smith reactions. In this reaction also nitrene have the roles. So it is an organic reaction in which an azide reacts with the carboxyl derivative, usually an aldehyde or ketone or carboxylic acid undergo acidic condition gives an amine or amide with expulsion of nitrogens. So formation of aniline. So thank you very much.